Imagine a world before steam power became part of everyday life. There were no steam trains rushing across the countryside. No factories filled with machines. No great ships crossing oceans with engines below their decks. In the 18th century, most heavy work still depended on people, animals, wind, and water. Deep underground, miners faced another problem. The deeper they dug, the more water they found. Pumps could remove some of it, but the machines were slow, wasteful, and expensive to run. Then, in Scotland, a quiet instrument maker named James Watt began looking at a steam engine and noticed something that others had missed. The machine was not useless. It was simply wasting too much of its power. That small observation would change the course of his life and help change the industrial world. James Watt was born in 1736 in Greenock, Scotland. His father was a successful shipwright, merchant, and builder. Young James grew up around tools, ships, ropes, wood, metal, and practical engineering. He was not the loudest child in the room. He was a careful observer. People who knew him later remembered his habit of thinking deeply about ordinary things. A piece of machinery could hold his attention for hours. A problem that seemed simple to someone else could become a question that he could not leave alone. Why did this part move? Why did that part fail? Could it work better? Those questions followed him into adulthood. As a young man, Watt traveled to London to learn the trade of making scientific instruments. He studied mathematics, mechanics, and precision tools. His goal was not to become famous. He wanted to become good at his work. When he returned to Scotland, he settled in Glasgow and worked as a mathematical instrument maker. His workshop was small, but his mind was always busy. Then, in 1763, a problem arrived that would change everything. The University of Glasgow owned a small model of a Newcomen steam engine. The machine was designed to pump water from mines. The university needed someone to repair it. Watt was asked to take a look. At first, the model seemed like a mechanical puzzle. Steam entered a cylinder. The steam helped move a piston. Water was then used to cool the cylinder, causing the steam to condense. The pressure difference allowed the piston to move again. The basic idea worked. But Watt noticed something troubling. Every time the engine completed a cycle, the cylinder had to be heated again. Then it had to be cooled again. Then heated again. A huge amount of energy was being wasted simply changing the temperature of the cylinder. Watt could see the problem. But seeing a problem and solving it were very different things. He began thinking about the machine constantly. One day in 1765, while walking near Glasgow, he had the idea that would define his career. The steam did not need to condense inside the working cylinder. Why not keep the cylinder hot and send the steam somewhere else to condense? The answer was a separate chamber. A separate condenser. It sounds simple now. At the time, it was a major breakthrough. Watt imagined steam leaving the cylinder and entering a separate vessel. There, it could cool and condense while the main cylinder remained hot. The engine would no longer waste so much energy heating and cooling the same piece of metal. He built models. He tested them. He failed. He tried again. The idea worked in principle, but turning a clever model into a reliable machine was another matter. Watt had limited money. His business was not large. He also lacked the resources needed to build large engines and test them properly. For years, his invention remained trapped between an idea and a working machine. And that period was difficult. Watt became deeply frustrated. His financial problems grew. His work demanded time and money, yet success remained uncertain. Then another man entered the story. His name was Matthew Boulton. Boulton was an industrialist who ran the Soho manufactory near Birmingham. He understood something that Watt was beginning to learn. A great invention needed more than an inventor. It needed money. It needed skilled workers. It needed materials. It needed customers. And it needed someone who could turn an idea into a business. Boulton and Watt became partners. The partnership gave Watt something he had badly needed, a place where his ideas could be developed on a much larger scale. But there were still problems. Building a steam engine was not like building a clock. Large metal parts had to fit together with remarkable accuracy. Cylinders needed to be bored smoothly. Pistons had to move with much less friction. Valves had to operate at the right moment. The technology of the time was not always good enough. Watt's designs could be excellent on paper and still fail in the workshop. So he kept improving them. His separate condenser was only the beginning. He developed methods for making steam engines more efficient. He worked on sealing the piston. He improved the way steam entered and left the cylinder. Then he faced another problem. Newcomen engines were mainly useful for pumping water. But what if steam power could do more? What if an engine could provide continuous rotary motion? That question opened a much larger world. Factories used machines that needed rotating movement. Mills needed power. Industrial equipment needed something more flexible than the back and forth motion of a pump. Watt worked on mechanisms that could turn the engine's reciprocating motion into rotary motion. This greatly expanded the possible uses of steam power. The steam engine was no longer just a machine for removing water from mines. It could become a general source of mechanical power. And that changed everything. But the change did not happen overnight. There were legal battles. There were technical failures. There were financial risks. Watt and Boulton had to protect their patents while convincing businesses that their engines were worth the cost. They faced competition from other engineers. They also had to build an organization capable of producing machines on a large scale. This was the less romantic side of invention. People often remember the moment when an inventor has an idea. They forget what comes afterward. The years of testing. The arguments. The bills. The broken machines. The endless adjustments. The need to convince other people that the idea will actually work. Watt lived through all of it. And slowly, his engines began appearing in mines and factories. The impact grew. A factory no longer had to be built beside a fast-flowing river simply because water power was available there. Steam engines could provide power in places where water power was limited. This did not mean Watt single-handedly created the Industrial Revolution. Industrialization had many causes, many inventors, and many technologies. But improved steam power became one of its most important forces. Factories could grow. Machines could run for longer periods. Mining could expand. Iron production could increase. Transportation would eventually change. and the relationship between people, machines, and energy began to shift. Watt himself was not a factory worker surrounded by smoke and noise. He was a thinker and engineer who spent much of his life studying how machines behaved. He was also interested in science. He worked with chemists and scientists and developed an understanding of gases and steam. He helped create technical terms and concepts that made it easier to describe the performance of engines. His name eventually became attached to a unit of power: the watt. It is a fitting legacy. Today, when we look at a light bulb, a computer, an electric motor, or another machine, we may see a number measured in watts. The word is so common that we rarely think about the man behind it. But Watt's life was not simply a story of success. He experienced long periods of doubt. His first wife died in 1773. He married again several years later, but the emotional strain of his earlier years remained part of his life. His health was not always strong. He sometimes struggled with anxiety and exhaustion. Yet he continued working. There was something about difficult problems that kept pulling him back. If a machine failed, he wanted to know why. If a design worked, he wanted to know how it could work better. That habit made him different. He was not satisfied with a machine that simply moved. He wanted to understand its efficiency. He wanted to understand where the energy went. And that way of thinking became increasingly important as industry expanded. By the late 18th century, steam engines were becoming more practical and more widely used. The world around Watt was changing. Cities grew. Factories became larger. Coal became increasingly important as a source of energy. Workers entered industrial workplaces where machines could produce more than human hands could produce alone. This brought opportunity. It also brought serious problems. Industrialization changed working conditions, cities, wealth, and social. It created new jobs but also harsh factory environments. It increased production but also increased dependence on coal and other fuels. Watt could not have predicted the full future of the technology he helped develop. He was solving the problems in front of him. That is often how history changes. People do not always know they are standing at the beginning of something enormous. For Watt, the beginning was a small steam engine model in Glasgow. He saw a cylinder heating and cooling. He saw wasted energy. And he asked a simple question. Could it be done differently? That question became years of work. And those years became machines. The machines became factories. The factories became part of a new industrial economy. Eventually, steam power moved beyond factories and mines. Steam locomotives would transform land travel. Steamships would change transportation across rivers and oceans. Railways would connect cities and regions. None of these developments can be credited to Watt alone. Other engineers played major roles, including Richard Trevithick and George Stephenson. But Watt's improvements helped establish the steam engine as a powerful and practical technology. His story also teaches something important about invention. The person who changes the world is not always the person who creates an idea from nothing. Sometimes the important person is the one who sees an existing machine and understands how to make it better. Before Watt, steam engines already existed. Thomas Newcomen's engine had been used for decades. Watt did not simply invent steam power. He improved its efficiency and expanded its usefulness. That distinction matters. Real progress is often built from older ideas. One person discovers a principle. Another improves it. Someone else finds a new use. Then another engineer solves a different problem. Over time, those small improvements can change society. James Watt spent much of his life working inside that process. By the time he became an older man, his reputation had grown far beyond his small workshop in Scotland. Universities respected him. Engineers studied his work. Industrialists wanted his machines. His partnership with Boulton had become one of the important engineering businesses of its time. But Watt never became the simple hero that later stories sometimes make him seem. He was human. He worried. He struggled with money. He made mistakes. He faced uncertainty. And many of his achievements depended on the people around him. That makes his story more interesting, not less. Because invention is rarely a single moment. It is usually a long chain of small decisions. A question. An experiment. A failure. Another question. Another experiment. And eventually, something works. James Watt died in 1819 at the age of 83. By then, the world he had entered as a young man was already disappearing. Steam power was becoming part of a new industrial age. Machines were changing the way goods were produced. Transportation was beginning to change. Cities were growing. Energy was becoming a central part of economic life. Watt had not seen all of this coming. But he had helped make it possible. His greatest lesson may not be about steam. It may be about curiosity. When Watt looked at the old Newcomen engine, he did not simply accept it as it was. He asked why it wasted energy. Then he imagined a better way. That is where his story begins. Not with a giant factory. Not with a famous invention. But with one person looking carefully at a machine and refusing to stop asking questions. The world was already changing around him. Watt simply learned how to make one machine work better. And from that improvement came consequences that reached far beyond his workshop. The hiss of steam. The movement of a piston. The turning of a wheel. The sound of machines beginning their work. For millions of people who came later, these sounds became part of modern life. And behind that transformation was a Scottish engineer who understood that sometimes the biggest changes begin with a very small question. Can this be done better?